Hello everyone. First of all, I have the honor to find between you, and also I thank the people who organized this congress. I am PhD student, followed by my dear directors Nadia Ahmed, Knut Philip, and Mariel Iron. The title of my presentation is Electrochemical Surface Treatments made on electrochemical TEU nanotubes ground on TE substrate, comparison of corrosion resistance and interfacial adhesion properties. I will begin with the introduction, then materials and methods, and finally I will finish my presentation by conclusion. Biomaterials is any material designed to interact with biological systems to evaluate, treat, augment, or replace any tissue, organ, or function of the body. Titanium and titanium alloys are widely used as bioimplant materials, particularly for orthopedic and osteosynthesis applications. Due to physical chemical stability, mechanical integrity, and good biocompatibility, and great corrosion resistance. But titanium materials are bio-inert nature, which means they have no chemical relationship and poor tribological properties Simple preparation. The starting material Brit was a commercial pure titanium grade 2 disc polished with various grades of abrasive papers, followed with 6 micro and 1 micro diamond pad. Finally, it was degreased in ethanol under ultrasonic conditions, rinsed with deionized water, and dried with compressed air. Surface modification. Nanostructuration. The samples were anodized in a solution of ethylene glycol containing fluorine ions and ultra-pure water at room temperature for 3 hours. The compact layers was performed in sulfuric acid baths for 1 minute, 30 minutes, and 180 minutes at room temperature. These figures show top view scanning electron microscope pictures of the structures formed after compact oxidation, which results in irregular cracks or wall coalescing on the surface, which are more and higher area common in C180 than in C30. However, no cracks seen in C1. And these figures show cross-sectional also picture of the structures formed after compact oxidation, whereas the blister in C180 is more longer than C30. Focalized ion beam FEB is a completer to scanning electron microscopy to examine cross-sectional structure. The thickness of compact layer is 121 for C1 and 137 nanometer to 160 nanometer for C30, and 2228 28 for C180. X-ray diffraction. The spectra were recorded in the range of 2 theta from 20 to 80 degree. The intensity of principal titan peaks decrease in sample C1, C30 and C180, which can be attributed to the greater oxide thickness obtained in acidic baths. It can be assumed that amorphous titanium layers were formed so no anatas or ritual phase developed on the treatment surface of titanium metal by oxidation compact at low voltage, which equal 50 volts. Corrosion test. For all electrochemical measurement specimens were studied at 37 degrees Celsius in dpbs. A 3 electrode cell was employed with a saturated calomel electrode AgCl KCl saturated as the reference electrode, a platinum foil as the counter electrode, and the studied sample as the working electrode. All samples were immersed in electrolyte for 30 minutes before the electrochemical test to achieve a stable open circuit potential. TOEFL plots measurements were recorded between mean 0.3 volt OCP and plus 1 volt reference at scale rate of 0.5 millivolts per second means 1. This figure illustrates the potential dynamic polarization curves of brute and C113 and 180. The corrosion potential was increased in C1 to C180 due to the compact layer thickness increased, whereas the corrosion resistance was better in C1 than C30 and C180 due to the present blister with different diameter. As a result of the diameter of blister increase the resistance of C30 is better than C180. We can conclude that nanostructured and compact layers obtained are amorphous without thermal oxidation. The presented research showed the possibility of creating oxides with a different thickness by means of electrochemical oxidation, while the corrosion behavior of titanium depends on thickness, compact layer, and so thank you for your attention.